In this second video, we're going to also look at representing quantitative data within state-level enumeration units. And so again, we have population data as we used in the previous one. We're going to click on our data set. And again, in this case, we go to our state. And again, we look at the change style symbol. I'm going to click on that. And rather than selecting the counts and amounts in terms of color, I'm going to choose the counts and amounts in terms of graduated symbols. In other words, you notice here it says size. That's really what we want to do. We don't want locations. We don't want types. That would be nominal data. We're going to select counts and amounts here. And we're going to check, in this case, our options. And so you'll notice it defaults to a symbol that is based on the quantity. And understand there can be two forms of symbols, size symbols. We can in fact have a graduated symbol, which means that our symbols in this case change size in discrete units, or we can in fact have a proportional symbol where the size is actually a function of the value. And in this case, again, you'll notice that our size symbols, in this case, we're going to set the same data we've already discussed in the previous video, the distribution of our data. But in this case, we want to use, in the last case, we used a quantile system, which means, again, an equal number of enumeration units in each class. Or we used a equal interval, which meant that the interval, the value range, was fixed at each one. Now we're going to use what's called a natural breaks, which in this case is a Jenks natural break, meaning that George Jenks' formula, or really an algorithm, for determining the breaks is used. In a simple sense, we can think about natural breaks as holes in the histogram or frequency diagram of the occurrences. And so in this case, what we're going to do is we're going to choose, again, natural breaks in 5 classes. And what we're going to see is that when we're done, again, we have in our legend 5 circles that represent our population. We can very easily tell the high population from the low. Now, one of the challenges of a graduated symbol is that they work really well when our data is far apart and each symbol is discrete in space. They become somewhat more problematic when the symbols overlap, as it is in the northeastern part of the United States. One way of resolving this is to look at our symbols and change the range of size. Now, there are some limits to this. So you'll notice right here we're using a circle symbol and our maximum size is 50. Well, I can shrink the minimum size here, and I can also shrink the maximum size. I'm going to bring that down quite a bit here, and we'll see what happens. Now, again, we have to understand that our minimum value has to at least be visible. So we have to be able to see a dot there. We're going to go to 5 here, and so we now have a stretch from this size, 5 points, to a 20-point symbol. And what that's done on the east is we have seen the change so that we can see virtually all of the states here. The problem with it, of course, is that then our points in the interior of the country become very small, and it kind of suggests a level of insignificance, which really isn't true. The other aspect of population density in this case is that, again, it suggests to some degree that the size is, in my opinion, again, when I look at this, the small top symbol suggests a lower level of magnitude. Another important thing that we want to think about here in terms of the symbology here is that Washington, D.C. symbol. And in that case, what we have is one outlier, significantly higher than the rest of them. And so we're going to deal with that as well. But for right now, we want to look at these symbols. I'm going to click OK. The other point that I want to make about counts and amounts in terms of size is that we can change this symbol in terms of what is an appropriate shape. And again, I'm going to go with a very basic shape. And you'll notice that some of these symbols are quite appropriate and some of them are really inappropriate. And so the more complex the symbol becomes, the less I believe it is an effective tool for these graduated symbols. So again, in this case, I'm going to change from a circle to a diamond, for example. And then in terms of my fill, I can use a single fill, and I'm going to eliminate the outline. I'm going to hit OK, and you'll notice that now these symbols look a little different. Now, one of the problems that we see already here is that without that outline, some of these symbols begin to fade into each other, or in terms of where they overlap, we can't see all the symbols easily. You'll notice right here, there are actually two symbols lying on top of each other, but we can't see them. So we have to be careful with our symbol choice, our outline form, and how a graduated symbol complicates a landscape of symbols. Okay, the last aspect of this that we're going to look at, and again I'm going to go into a kind of just a simple explanation here, is that so far we've seen natural breaks, equal interval, quantile, and then of course we could use a manual break where we insert the divisions. The other one that we have not seen is a standard deviation, and a standard deviation is a classification scheme that, again, in my opinion, should be only applied to a color gradation, that is a choropleth map, so that we see the middle value and the colors depart from either side from that. So again, we'll see that in another exercise when we begin to pull apart and deal with our data. Till then,